Hello. Hello, Isaiah. I'm glad you made it back. Sorry about the confusion on our first go around. I will start writing up a question so we can start thinking about it. Find two positive numbers. Whose product is 100. And whose sum is a minimum. All right, we have a couple more people here. If you could sign in, please, so I could know who's here. Just write a comment. And we can get started here shortly. Hello, Matthew. Glad you found your way back. So we're waiting for Greg and Eileen and Joseph. So while we're waiting for them, take a look at the question that I have here. Find two numbers whose product is 100. So we're going to start with x times y is 100, and whose sum is a minimum. We're going to try to minimize the sum using the first fact that we have, our constraint equation. And hopefully they're going to get into hello, Eileen. Okay, we now have 3 out of 5 as we wait for Greg and Joseph. So while we're waiting for them, I guess I can go ahead and get started. Two positive numbers whose product is 100. So first off, I'm going to say my two positive numbers are going to be x and y. We're saying their product is 100, so I know that x times y is 100. Oops. X times y is 100. And our goal is to minimize that. We want to minimize the sum is a minimum. So we want to minimize x plus y. But I only want to go ahead and figure out a function of one variable only. So right now I have x times y is 100. The product is 100. So if that's the case, y is 100 divided by x. So instead of minimizing x times y, x plus y, I can minimize x plus 100 over x. So that's the function that I need to be at. Joseph, welcome. I'm glad you're here. So hopefully we can get Greg here soon. So this is the function that I want to optimize. I want to find the smallest x value that will minimize that function. So my goal is to minimize the function f of x is x plus 100 over x. So what are the tools that we have to optimize? We have the first derivative test. Remember how that worked? We had to find critical values, critical value C, critical value C. And then we looked at arrows. If it went up, down, up, we would say we have a max at C1 and a min at C2. That was another strategy that we had. And we also had the second derivative test. Recall how that works? The second derivative test, we found our critical values again. Critical values C1 and C2 where the first derivative is 0. And then if it was concave down, we would have a max. If it was concave up, we'd have a min. So those are the tools that we have to optimize. We're going to go ahead and take the first and second derivative of this thing and then see how it behaves in terms of getting our critical values. So let's go ahead and do that. What do I have? I have f of x, which is the same as x plus 100 x to the negative 1. And if we are finding critical values, we've got to take the first derivative and set it equal to 0. So what is f prime of x? The derivative of 1x is just 1. The derivative of 100x to the negative 1 is plus 100 negative 1 x to the negative 2. So I get f prime of x is 1 minus 100 x to the negative 2, or f prime of x is 1 minus 100 over x squared. So remember, our goal is to find critical values. Goal, find critical values. So how am I going to do that? What am I going to do? I'm going to set f prime of x equal to 0. So we'll say 0 is 1 minus 100 over x squared. Solving for that, then I get 100 over x squared is 1, which tells me 100 equals x squared, which tells me x is plus or minus 10. I will assume in this situation that x is positive. So if that's the case, x is 10. But remember what we started with? We started with the fact that the product was 100. So initially, our product, x times y, is 100. So I've just established that x is 10. So knowing that, then I will say 10 times y is 100, or y is 10. So what were we trying to do? What we were trying to say? We wanted to find two positive numbers. We wanted the product to be 100. We wanted the sum to be a minimum. So my sum is 10 plus 10, which is 20. My product is 10 times 10, which is 100. Now, you think about it. If the product is 100, we could also have had 25 and 4. But 25 plus 4 is 29, more than 20. I could have had 50 and 2. 50 plus 2 is 52. So the fact that this thing is a square, x and y are equal, tells us something about the geometry that we're using to make this work. So let me go ahead and ask you a similar question, and let me have you try it to see if you can do it. Find a positive number and twice its reciprocal is as small as possible. So go ahead and try that. Get it set up, please, and see where you go. Greg, are you back? I see I have 6 people here. So I assume he is. All right, go ahead and set that up if you can and get it started. We'll take a look. Very good. So again, I want you to work on this one and see what you get. If you think you have an answer, go ahead and post it. I'll take a look at it. What is that number? Such that the sum of that number and twice its reciprocal is as small as possible. Eileen's giving us a number around 2. You have anybody else with a similar answer? That would be 2 plus a half, right? No, 2 plus twice its reciprocal. So 2 plus 2 halves would be 3. Joseph has the same. Let's see what I get. All right. So we have the number is x. Its reciprocal, twice the reciprocal, is 2 times 1 over x. So we want to minimize that sum. We want it to be as small as possible. So my f of x is going to be x plus 2 over x. Now what I need to do is I need to find the critical values. At some point I need to try to convince myself whether it's a minimum or a maximum. So let's talk about that. So what are we going to say here? What is f prime of x? Well, first of all, f of x is x plus 2x to the negative 1. So f prime of x is 1 minus 2x to the negative 2. So I get f prime of x is 1 minus 2 over x squared. Now to find the critical values, I have to set f prime of x equal to 0. So I'll take 1 minus 2 over x squared equals 0. So 1 equals 2 over x squared. 1 times x squared is x squared equals 2. We've got a lot of folks with 2. Is 2 our answer? If x squared is 2, what would that make x? If x is a positive number, x would be the square root of 2. So let's take a look at some numbers to see what's going on there. Now, first of all, can I convince myself if that's really a minimum? Is it a minimum or is it a maximum? So what I have is, I have f prime of x is 1 minus 2x to the negative 2. Let me go ahead and appeal to the second derivative test. If I appeal to the second derivative test, f double prime of x, the derivative of 1 is 0 minus 2 times negative 2 x to the negative 3. F double prime of x is 4x to the negative 3. F double prime of x is 4 over x cubed. Now, if I plug in my critical value is root 2. F double prime of root 2 is 4 over the square root of root 2 cubed, which is positive, right? So if my concavity is positive, it's bending upward, and we'll have a minimum. So min at x equals root 2. Do we really believe that? Let's take a look at some numbers. So I want to take a look at my function. My function is x plus 2 over x. If I choose 1, I get 1 plus 2 over 1, which is 3. If I choose 2, I get 2 plus 2 over 2, which is also 3. If I choose root 2 that's in between, I get root 2 plus 2 over root 2, which is root 2 plus root 2, 1.414 plus 1.414, so 2.828, which indeed is smaller. So my answer on that one is indeed square root of 2, not quite 2. So let's watch our arithmetic. We seem to have a virus, no pun intended, of some bad arithmetic on that one. Okay, let's go on to one of our favorite questions of all in the world of min-max problems. So I have a river, and I have a farmer who is building a 3-sided fence, and he has a total of 1,200 feet of fencing. So there's no alligators, crocodiles in this river to worry about. So he just wants to go ahead and build this pen to maximize the area. We want to max area. So how do we do that? How do we build this fence so that we get the maximum area? So we're going to go ahead and lay this out. This distance we'll call x, which should be the same as this one. And this one we'll call y. So our area here is x times y. So we know that he has a total of 1,200 feet of fencing. So if I put that together, what I would say then is x plus y is 1,200. Two x plus y is 1,200. So y is 1,200 minus 2x. Our goal is to maximize the area. So if I maximize the area, what is the area? The area is xy. So the area is x times 1,200 minus 2x. And this is what we want to maximize. So my area as a function of x is 1,200x minus 2x squared. So if I'm going to do this, I've got to take the derivative and set it equal to 0 to find my critical values. So a prime of x is 1,200 minus 4x. Set a prime of x equal to 0. So that gives me 1,200 minus 4x. So 1,200 is 4x. Divide by 4, divide by 4. 300 is x. Now, do I know if that's a minimum or a maximum? You see, I neglected to do that on my first problem where we had the numbers, the 10 and 10, but we checked some numbers around it, and that indeed was smaller. But let's be a little more formal here. X is 300, so this distance is 300. This distance is 300. He has a total of 1,200 feet of fencing, so this one is a total of 600. So looking at that, we can identify the fact that x is 300, y is 600. So what's my area? Area is x times y, which is 300 times 600, which is 18 with 4 zeros. Now, is that a minimum or is that a maximum? And I really think the safest way for us to get there is to, again, use the second derivative test. So here is my first derivative. My first derivative is 1,200 minus 4x. So a prime of x is 1,200 minus 4x. So set a prime of x equal to 0. So 1,200 minus 4x equals 0. So 1,200 equals 4x. I don't know what I'm doing. Take 2. I already have the critical value. A prime of x is 1,200 minus 4x. What's the second derivative? A double prime of x is -4. What is that? That is concave down. That is concave down, so the function achieves a maximum. At the critical point. So I know for sure that we have a maximum area of of how much? Of 180,000 square feet when the pen is built this way, river, 300, 300, 600 feet. So the second derivative gives that to us. Second derivative gives that to us. All right, let me go ahead and ask you folks to try another problem. So again, the pen along the river is a classic. Here is another fairly standard question that we do in calculus. So let me ask you to try this first. Find the point on the line (6x plus y equals 9) that is closest to the point (-3, 1). So let's draw ourselves a picture, and then I'll let you work on it a little bit. So if x is 0, y is 9. If y is 0, x is 1.5. So it's coming down like this. Okay, I missed. Then we went to point (-3, 1). So where is the point on the line closest to this point (-3, 1)? That's what we want to find. Okay. So we need to figure out some way to do this. And I think the simplest way to do this is to pick a generic point on this line, call it x comma y. And rather than looking at distance, let's look at distance squared. Distance squared is change in x squared plus change in y squared. So we can look at that. Change in x is here. Change in y is there. And there's my distance squared. So my distance squared, which is what I'm going to choose to minimize, is from (-3 to x, x minus (-3). Change in x squared would be x plus 3 squared plus change in y squared plus y minus 1 squared. And if I can minimize the distance squared, then I can also minimize the distance. This is our idea. What should I do next? Who's got an idea about how I can rewrite this? So I'll wait for a comment to see if someone has a comment for me. What's my next move? If you want a hint, f of x equals, what should I do? What is my next move? Greg is thinking. That's good. I hope everybody is. I don't need a final answer. I just want to determine what's the next step I've got to take in the process. Not yet, because I have two variables, Isaiah. I have both x and y. I want to have a function of x and x alone. But I will find a derivative, absolutely, once I have my function defined. So what's my next move? Joseph's got x times x plus 3 squared plus y minus 1 squared. Not quite, Joseph. You're trying to do some substitution. Matthew says solve for y. I like that one. Do you see what we have here? We have 6x plus y equals 9. If that's the case, yes, Joseph, then take the first derivative. If 6x plus y is 9, then y equals 9 minus 6x. So I'm going to go ahead and I'm going to plug that in for y up in this equation. So I have x plus 3 squared plus y minus 1y, 9 minus 6x minus 1 squared. Then we want to take the derivative. Then we want to set that equal to 0. So let me ask you folks to go ahead and finish the problem. So find the value x and the value y, the point on that line closest to the point negative 3, 1. See what you can do. When you have an answer for x, post it on the comments. Well, the algebra here gets pretty nasty. So let me walk you through what I did here. X plus 3 quantity squared, x squared, 3x plus 6x plus 9. 9 minus 6x was y, I need y minus 1 squared, so 9 minus 6x minus 1 squared. That's 8 minus 6x squared. 64, 8 times negative 6x, negative 48, negative 48, negative 96x. Negative 6x times negative 6x, positive 36x squared. So 1x squared and 36x squared is 37x squared. 6x minus 96x, negative 90x. 9 and 64 is 73. That's f of x. Then I need f prime of x, taking the derivative of that. What do I get? 37 times 2x, 74x minus 90. To get the critical value set, f prime of x equal to 0. So 0 equals 74x minus 90. 90 is 74x divided by 74 divided by 74. And I get x as, what is that, 45 over 37. Just a little bit more than 1, which I think I could believe looking at my picture. And to get the y value, y is 9 minus 6 times 45 over 37. Which is, that's, I don't know, close to 2. So I'm gonna have to check that on Desmos, I think, to get a good visual of what's happening there for our x value. 9 minus 6 times 45 over 70, or 74. There's my problem. No, 37. Okay. All right. Well, I will check that one for you, but I'd like to move on. Let's take a look at one more problem here. Here we go. A box with a square base and open top. Must have a volume of 32,000 cubic centimeters. Find the dimensions of the box that minimize the amount of material used. So a couple things we've got to get here from this. Square base and volume of 32,000 cubic centimeters. So knowing that, let's draw ourselves a picture. So the base is square, so what's sitting on the ground, these two distances are the same. The height I will call y. So we know the volume of a box. The volume of the box is length times width times height. So the volume in this case is x times y. So the volume is x squared y, but the volume is 32,000 cubic feet. So 32,000 is x squared y. I want to minimize the amount of material used. So how do I figure the amount of material used? Looking at my picture, I have an open top. That's important for us to recognize, so there is no top. But I have a bottom, left side, right side, front side, back side. Bottom, left, right, front, back. So this box has 5 different sides. The bottom is x by x. Bottom is x squared. The left side is x by y, xy. The right side also x by y. The front also x by y. And the back x by y. So that the surface area is adding all those together. Surface area is x squared plus xy plus xy plus xy plus xy plus 4xy. But I'm only allowed to have one variable. So what is the next thing I have to do to complete this problem? What's my next move? Currently, I have surface area is x squared plus 4xy. What would I do next? Post in comments. What do I do next? Waiting for a suggestion. Solve for y. Yes, Joseph, solve for y. And what I had before is I have 32,000 as x squared y. Divide both sides by x squared. 32,000 divided by x squared is y. So now I have surface area is x squared plus 4x times 32,000 over x squared. So my function f of x that I want to work with will be x squared plus 4 times 32, 64, 128,000. Divided by x. So let me ask you to go ahead and find the minimum value, or find the x value that will minimize the surface area. So go ahead and find that critical value and see what the x value would be. Convince yourself that it's a minimum. And then also, what is the y value? So another minute or two to work on that one. So I have f of x is x squared plus 128,000 over x, which is x squared plus 128,000 x to the negative 1. So what is f prime of x? 2x minus 128,000 x to the negative 2. Set f prime of x equal to 0. So 0 is 2x minus 128,000 over x squared. 128,000 over x squared equals 2x. Multiply both sides by x squared. 128,000 equals 2x cubed. Divide by 2. 64,000 equals x cubed. Cube root of 64,000 is x. That is 40 is x. So if you remember, what did our original thing look like? What did we have? We had a square base. So this is 40 and this is 40. And this last part was y, but our total volume was 32,000. So again, what I need is what? I need (40 times 40 times y) equals 32,000. 1,600 y equals 32,000 divided by 1,600. Divide by 1,600 and I get y is 20. So I could find the minimum surface area, right? The minimum surface area. And we would convince ourselves it's a minimum by taking the second derivative test again. I will leave that to you as an exercise. So the minimum surface area, remember, because our surface area was what? Was x squared plus 4xy. The minimum surface area is x squared, 40 squared, plus 4 times 40 times 20. So we get what? 1,600 plus 800 times 4, 3,200, which is what? 4,800 square feet. And that would minimize the cost likely of constructing such a box. Okay, well, I have found in the past that it doesn't make a whole lot of sense to do these video lectures any more than about 45 or 50 minutes. So here is what we will do going forward. I will post this on YouTube, so you'll be able to watch all of these problems again. First thing is I will send you a quiz sometime in the next 24 hours. So quiz will be due before class on Wednesday. I use an app called Cam Scanner. Cam Scanner. What that does is you can do your work on paper like I'm doing and take photos with your phone, convert it to a PDF, and then upload it. That'll be the easiest way, I think, for you to do this. I'm going to ask you to watch another video or two. So I will send videos for you to watch to finish up our time today. And I want you to get started on Webassign. Since we are web enabled now for the rest of the semester, I had to increase the level of Webassign questions. So I have given you a little extra time to finish the previous Webassign. If you didn't get that done, I've given you an extra week. So get that done and get started on the Webassign that will be due the day of our next exam. Hopefully we're back in class by then, but we'll see how things go. This is challenging. Word problems in calculus are challenging. So like I said, watch this video again. Make sure you can do these problems. Watch the video I'm going to send you. Get started on Webassign and have the quiz done before I talk to you in the same format on Wednesday. That's all I have for you. Thanks much, and we'll talk soon.